Okay, so let's start right here with part 2 of our trig equations. And we finished yesterday kind of rushing through this problem, so we'll take our time and slow down and cover it better. What's different about this example and the previous examples that we've looked at is that instead of dealing with x as an angle, we're dealing with 4x. But we still have x here. So whenever you see a difference between the angle in the problem and the angle in your domain, we need to make the two things match up. Okay? Now, it would take a whole lot of work to turn 4x into x on this side. You could use some trig identities and play around with it and make that x, but you'd end up with a mess as your equation. So we want to keep the simple equation, and we want to adjust the domain of the function to match the angle that's in the problem. So I need this to be 4x. And I can turn it into 4x simply by multiplying through this inequality by 4. And that would give me 0 is less than or equal to 4x, and 4 times pi over 2 is 2 pi. And now my angle in my domain matches my angle in my problem. Okay? Does everybody see what we've done? And that's just going to be standard procedure. If we can't easily change the angle, and we're going to look at some today where we easily change the angle, we're going to make the interval or the domain match the angle that's in the problem. And you do that by multiplying through that domain interval by 4. Okay, we're going to follow suit here. We're going to isolate the variable or isolate the trig function. And when we do that, we get cosine 4x equals negative square root of 3 over 2. Right? We got this far yesterday, I believe. Which tells us that our reference angle is, what's our reference angle for cosine? Is root 3 over 2. Pi over 6. And the quadrants where the cosine is negative, quadrant 2 and quadrant 3. So my angle, which I need to remind myself, is 4x. My angle is in quadrant 2, quadrant 3, pi over 6. So pi over 6 here, pi over 6 here. Okay, this angle is, somebody help me tell me what this angle is. 5 pi over 6. And the other one is 7 pi over 6, that's correct. 7 pi over 6. 4x is equal to those two things because 4x is our angle. Okay? Now, when have you ever in algebra or any math been asked to solve for 4x? Never. So we want to finish solving this for x. And that means we're going to divide everything by 4. Which is the same thing as multiplying it by 1/4. So x is equal to 5 pi over 24 or 7 pi over 24. And that's all the answers because we're only allowed to go 0 to 2 pi for 4x. And these two answers are, we need to double check and make sure that they're in the interval that we started with. And they will be because we just divided by 4 to get back to where we were. All right, it's easy enough, right? Especially after you've wrestled with last night's homework and figured out these two questions here, the reference angle and the quadrant are the most important things in the mix. All right, so let's get a little bit more complicated. Now, what we're going to do today is going to involve some simple trig formulas and, some simple trig identities and a little bit more complicated algebra than we've been dealing with so far. All right, that was homework last night. Part 2, solving trig equations is easy when the angles are the same and there's only one trig function. So what we're going to look at today is some equations that have sine and cosine in them. All right, and different angles. One might be a 2x and the other angle is x. So we're going to have to use some trig identities and or some algebra to make the angles the same. When there are different angles and different trig functions, other techniques must be employed. To get the angles the same, you must use a trig identity. So we're always going to be, and this is going to be primarily using that familiar sine of 2x identity or cosine of 2x identity. So let's remind ourselves what sine of 2x is. This is the one we'll use the most. What is sine of 2x? 2 sine x cosine x. And this is really helpful because it's an identity that changes the angle. It changes the angle from 2x to x. It's a double angle identity. Cosine of 2x was cosine squared minus sine squared. Is that correct? Cosine squared of x minus sine squared of x. And because we can make substitutions for either of these, 1 minus sine squared or 1 minus cosine squared, we can express these as 2 cosine squared x minus 1, or we could do it as 1 minus 2 sine squared x. So those identities are going to come into play when we're solving trig equations. Okay? If we can get the same angle, we will. If we can't, if we can get the same trig function, we will. If we can't, then we have to use some factoring techniques, which we're going to look at right out of the blocks with our first example. Okay, so let's look at, for our first example in part 2, sine of 2x equals cosine of x. Sine of 2x equals cosine of x, and we're just going from 0 to 2 pi. We're not going to restrict our domain any more than that. We're not going to look at all real answers. We're just going to look at 0 to 2 pi. Excuse me. Now, obviously, the obvious difference here in context of what I just said is that our angles are different. We have sine of 2x and we have cosine of x. You're going to need to make your equation have only one angle value in it. And this is where our good friend sine of 2x equals 2 sine x cosine x is going to come in handy. Okay, now any ideas here? Could we divide cosine x out of the equation?
Yeah.
If we did, watch, don't write. If we did, we would get sine x, 2 sine x equals 1, right? Sine x equals 1/2, right?
Mm-hmm.
It'd be really nice if we could do that. But we can't do that. Why can we not do that?
Because can't switch sides, can't bring it over to the other side.
Now, I mean, I've divided both sides by the same thing, so it appears that I've done a legal operation here.
Wait, you're only supposed to work with one side?
No, we're supposed to work with both sides. But I've done something here that is a big no-no in math. I may have divided by 0 because I don't know what x is. And since I don't know what x is, the cosine of x might be 0. And if you divide by 0, then you have messed things up. All right, this goes back to the algebra equivalent of this. The algebra equivalent of this, if I had x squared equals 4x, this is the algebra equivalent. I'm having technical difficulties here. Can we divide both sides by x there? If we did, we would get what? X equals 4? But what happens when I do that? I lose a solution, don't I? How are we supposed to do this problem? No, we're not going to do the square root. We're going to set it equal to 0. Remember, in a quadratic expression, if a square shows up, we set it equal to 0. Then what are we going to do to that? We're going to factor it. X times x minus 4 equals 0. And that means our two solutions would be x equals 0 or x equals 4. Now, we can get that solution from here, from the original equation, if we divide both sides by x. But we lose this solution, and it just so happens that x is 0 is one of the solutions. So when I divide by x, I am dividing by 0, which is a big, big no-no in mathematics. All right, now, we are going to employ the exact same technique in this trig equation that we just did in this algebra equation. We're going to set it equal to 0. Y'all follow with me. 2 sine x cosine x minus cosine x equals 0. Now, in the algebra expression, the algebra equation that we're working with over here, we factored out an x. Is there anything that we can factor out of our trig equation? We can factor out a common factor of cosine x. And that will leave us with 2 sine x minus 1 equals 0. And by the 0 product rule, that tells me that either cosine of x must be 0. Ah, there you go. See, when we divided by cosine x earlier, we divided by 0. Because cosine x is equal to 0 in this problem for some values of x. The other one would be 2 sine x minus 1 equals 0, which means the sine of x equals 1/2.
Is this an and or is
And that's
it
your
an or?
answer.
This is or.
Okay, that's what I had put, but I
Yeah, this is an or deal. Well, these are the two simple equations that match last night's homework.
And then you just solve
And
it.
x is here. So we have to now, once we have these simple equations here that we can solve, we can finish the equation. Okay?
So you're finding two answers.
We're going to have at least 2 answers. We may have 4 answers.
Does they could each have 2?
Yes, because each one of these equations could have 2. So when you start mixing different trig functions, you can see that the techniques get a little bit more complicated right out of the blocks. So we're going to have to employ some algebra techniques, some factoring. You'll just about always be factoring if you have 2 trig functions.
How did you get cosine x equals 0? Like,
All right.
that was
When you get to this point, we're multiplying 2 things, right? We're multiplying cosine x times this. And by the 0 product rule, the only way you can multiply and get 0 is if one of those things is equal to 0. The same way over here, we had x times x minus 4 equals 0. That means either x equals 0 or x equals 4.
so like
The product rule, 0 product property says if 2 things multiplied to be 0, then one of those things has to be 0. So you set them both equal to 0 and solve. Okay? All right, so does everybody have this written down?
Do you have to do the right side, x squared equals 4x?
No. That was just an example of why we couldn't divide both sides by an unknown value, because the value might be 0.
That's not right.
No, we're not finished.
Okay, that's
What
fine.
we've reduced this to is our 2 solutions are going to come from cosine x equals 0, or our 2 sets of solution or sine x equals 1/2. And I ran out of room, but you guys didn't, so we're good to go.
So those were not answers.
No, our answers have to come from here. Remember, we're trying to solve for x. I want to know what x is equal to. The end result is going to be x equals some angle. X is an angle, so I want angles for my answers. All right, where is the cosine of x equal to 0 between 0 and 2 pi? Pi over 2 and 3 pi over 2 is correct. Then you get that straight from your unit circle. Where is the sine of x equal to 1/2? Pi over 6 in the first quadrant, which is just pi over 6. So there's another answer. But it's also pi over 6 in the second quadrant, which is 5 pi over 6. I said 6 in row 2. So our four solutions to this equation are pi over 2, 3 pi over 2, pi over 6, or 5 pi over 6.
I don't know how I feel.
Probably a little bit confused and a little bit overwhelmed. This is the first example, so that's okay.
It's,
Yeah.
it's alright, but it's like,
So if you plug like each of those back into the equation for x,
Yes,
would it equal each other?
it certainly would. They would equal each other. You want to let's do that just as an exercise. And
Where did you get all those numbers
where did I get them?
Yeah,
Okay, cosine of x equals 0,
that's pi over 2.
or 3 pi over 2. Cosine is 0 at pi over 2. Cosine is 0 at 3 pi over 2 on your unit circle. Sine of x equals 1/2. Pi over 6. 5 pi over 6.
that circle is mine.
The circle is great. The unit circle works good. If you're referencing your unit circle to get these angles, that's fine. That's why we use it. Okay. You'll get more and more. We'll do this enough so that you will get more and more accustomed and less dependent on it. But the unit circle is great, particularly for the quadrantal angles, the pi's over 2's, the 3 pi over 2, 0, and pi. The zeros and the 1's. The unit circle is particularly helpful to remember those. Okay? Let's move. I'm going to click on through this. We were going to check those answers. Let's get another example or two in instead of that. Too many clicks here. There we go.
Oh, that's all reals, right? Low key.
Yes. 3 tangent squared of x equals 1. What's different about this problem?
Squared.
It's squared and
Equals 1/3. Sort of.
it's tangent. That's a little different, right? And it's all real numbers. But this one's going to be kind of like problem number, whichever one, 5 or 9 that we worked with last night. It's a tangent problem, and it's all real numbers. And because the period of the tangent function is pi instead of 2 pi, we can do plus k pi instead of plus 2k pi. All right, but let's look at this. What would you do first of all? What are we trying to isolate here to get a solution? We want to make this look like last night's homework. So ultimately we're trying to solve for x, but we need to get the tangent of x by itself. I don't know anything about tangent squared values.
You don't? Yes, you do.
I do, but you know, if you square all your tangent values from that table of values, you would get that. But there's something that's going to happen here. We're going to divide by 3, which Emma, you already said was a good idea to do. So if we divide by 3, we get the tangent squared of x equals 1/3. Now, how am I going to isolate the tangent now? How am I going to get tangent by itself? We're going to take the square root of both sides, and we have to remember that the square root property says if x squared equals b, then x equals plus or minus the square root of b. So when we take the square root of both sides here, the tangent of x is going to equal to plus or minus the square root of 1/3. this shouldn't be here. This is erroneous. Plus or minus. Okay? Now, I know my reference angle, right? What's my reference angle for tangent is 1 over the square root of 3. Pi over 6. So my reference angle is pi over 6. And I'm in which quadrant?
Well,
Or,
it's plus or minus.
It's plus or minus, right? So I can be in all 4 quadrants. I want all the positive tangent values and all the negative tangent values, so that puts me in all 4 quadrants, right? Okay, so I'm gonna click through this and kind of let you see what goes on here. Because it's all real numbers, the tangent is positive in the first quadrant and the third quadrant. All right, so that gives me pi over 6, and this is going to go ahead and do the plus 2k pi. That's okay. We'll talk about how we can condense it later if you'd like. And then in the tangent's positive in the third quadrant, which is, I wouldn't go in a negative direction just because I don't like to. Let's go in a positive direction. What is that angle? 7 pi over 6, right? And in the second quadrant, it would be 5 pi over 6, and in the fourth quadrant, it would be 11 pi over 6. So the 4 angles that we're going to be dealing with here are pi over 6, 5 pi over 6. I don't like that. Yeah, here we go. Pi over 6, 7 pi over 6,
So all those are the answers.
11 pi over 6, and 5 pi over 6. Plus 2k pi. Yeah, because the tangent is positive or negative in all 4 quadrants.
Why is it plus 2k
Because it's all real numbers, all real angles. Now, here's the deal though. This is the kind of the tricky part with the tangent that we saw in our last night's homework, and we'll see it in this night's homework. Pi over 6 in the second quadrant is 180 degrees away from pi over 6 in the fourth quadrant. Right? And which is pi. There's a distance of pi between these 2 angles, so plus pi. So I can get these 2 answers, the pi over 6 and the fourth quadrant angle. I can get those from just saying pi over 6 plus k pi instead of 2k pi. And similarly, the first quadrant pi over 6 is 180 degrees from the third quadrant pi over 6. It's pi. There's pi between these 2. And so that gives me 5 pi over 6. Excuse me, I had that wrong. The second and third quadrant angles would be 5 pi over 6 and 11 pi over 6. Then these 2 angles, first and third quadrant angles, I could write as pi over 6 plus k pi.
So, pi over 6 plus k pi.
I mean, do we have to write like that? Or can we write like?
No, you can write it either way. I'm just saying that the textbook answer is probably going to be this. I'll shoot you guys a couple problems that I want you to work on over the weekend, not very many. We'll continue this lesson on Monday.